8.1 Common monomial factors. Our objectives are to find the greatest common factor of two or more monomials, and then to factor polynomials using this greatest common monomial factor. First, let's talk about what the greatest common monomial factor is. It's the product of all the integer and variable factors that are common to, or in another way to say it's shared by, those monomials. So first we need to split up our monomials into their factors. Remember, for our constant numbers we do factor trees. So I know 4 is made up of 2 times 2. When we consider our variables, remember that m squared is really m times m, and n squared is really n times n. This is not a polynomial, these are just two unrelated monomials. So let's factor this one here, m times m times m times n. So this is the list of all of the factors here, and I'm going to go ahead and circle all the ones that are the same in both lists. So I have one m here, 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 I have one n here, I have one n there. Nothing else is shared in both lists, so nothing else can get included in our greatest common monomial factor. Therefore, our greatest common factor is going to be m squared times n. So once we've figured out our greatest common factor, we can then move to factoring an entire polynomial. Factoring is the reverse of multiplication. That's what we're going to be doing in all of this chapter, is factoring. So we're taking things out of multiplication, which hopefully should be triggering in your mind the word division, right? Division is the reverse of multiplication, so we must be doing division here. In order to do this, we're going to find our common factor, which we just talked about doing. Then we're going to divide each term in the polynomial by that factor. And we're going to write our final answer as a product of the common factor and the quotient polynomial, which of course is the result of our division. So let's see how this works. Let's say we have the following binomial, has a degree of 5, right? Degree of 5. And we need to factor it. So first we need to figure out our GCF. It's our first order of business. For your variables, it's usually very clear looking at them, right? I can see how many x's are shared. There's going to be 2 x's shared. I can see how many y's are shared. There's only 1 y shared. For your numbers, though, if they're more complicated numbers, you still need to do your factor tree. Okay? Now, I can cheat a little bit here because I know that 54 is 6 times 9, and since 9 showed up over here, obviously their common factor must be 9. So my greatest common factor is 9x squared. If there wasn't something immediately obvious like that one, you might have to factor them completely and then do your normal greatest common factor method that you already know. Okay, now that I have the greatest common factor, that goes outside. Inside the parentheses, I'm going to put my quotient after I divide everything by the greatest common factor. So I'm going to take it one term at a time. Let me go ahead and get rid of this work here so we have a little room to work. We're going to take each of these and we're going to divide it by what we've determined to be the GCF. Okay, and then I'm going to simplify that. Remember, top minus bottom on our exponents. 9 and 9 simplify to 1, which I don't need to write. 2 minus 2 simplify to 0, which gives me x to the 0, which equals 1, which I don't need to write. And then 3 minus 1 on my y is going to give me y squared. So all I have left there is y squared, because this is what it looked like, and all of this just equals 1, which we don't write in visible ones. Then I've got 54 divided by 9. That's going to give me 6. I've got 3 minus 2 on my x's, so I'm left with 1x. I've got 1 minus 1, which gives me y to the 0, which equals 1, which we don't write. So there we go. Let's move this over a little closer. Here is our final factored polynomial. So we have not changed anything about the polynomial. It's still the same polynomial. It's just in a different form. Now it's in the factored form. Okay, so how do you factor completely then? A polynomial is factored completely when no other common factor can be extracted from it. So let's look at this polynomial right here. That's somebody nicely factored. Is it factored completely is what you have to ask yourself. Look at the part on the inside to answer that question. Is there any common factor between these two terms? Now, hopefully you've already thought about it. Well, yes, both of these are divisible by 2. Therefore, there is a common factor. So what we do is we go ahead and divide both terms by 2, and that 2 gets to come and be part of the GCF out here. So that becomes 14x cubed. That becomes 2x squared as it's divided, and that becomes plus 5. Now we look at our polynomial again and ask ourselves, looking at the part on the inside, is this factored completely? And now we can say yes, it is, because there's no greatest common factor left between these terms. A prime polynomial has terms with no common factor. So here's a nice example here, 27y cubed and 35. There are no common factors between those numbers and between the variables, so that would just be prime. Let's do one more practice about factoring completely. If you pull out your GCF correctly the first time, you will automatically factor completely. If you make a mistake in your GCF, you may have to factor 2 times to get it factored completely. Okay? So let's look at our GCF here. We know that this is going to be 3 times 6, which is 2 times 3. This is going to be 4 times 6, which is 2 times 2 and 2 times 3. And this is just 6, which is 2 times 3. Clearly here we can see a common factor, which is the 6, right? So we're going to have 6 in our greatest common factor. For our numbers, let's look at our variables. I've got 3, 2, and only 1x there, so we can only include 1x. I've got 2y's, 2y's, and 2y's. Okay, great, so we can do 2y's. I've got 1z, but nothing else to match it, so we can't include any z's. Okay, so there's our greatest common factor. Now let's go ahead and divide all of our terms by 6xy squared. 6xy squared, 6xy squared, and 6xy squared. Okay, 18 divided by 6 is going to be 3. For the x's, I have 3 minus 1. Let's get another color here. 3 minus 1, which is going to leave me with x squared. The y's are going to cancel themselves out, and I have a z there. Minus 24 divided by 6 is 4. 2 minus 1 leaves me with 1x. The y's cancel. The whole thing cancels out, but remember, that means you have a 1 on top and bottom. So we have plus 1. So this is our inside, and remember we put our greatest common factor on the outside because we write our answer as a product of these two factors. Now to double check yourself, you want to look on the inside here and ask, are there any greatest common factors I have missed? Doesn't look like it, so I would say we're done. Try these, do number 1 through 9, only the odds.